These next couple of problems will give us some examples of what happens when problems have no solution or all real numbers as their solution. So we still solve these in the same way. Our first step in this problem is the distributive property. Distributing the 4 to the 2p and the negative 7. Then I'll combine my like terms on the right side to get 9p minus 28. Here's where something's going to start to look different. Remember, I want to get all of my p's to one side of the equation. So if I subtract 9 p's from the left and the right, they cancel out on both sides, leaving me with only a 4 on the left side and a negative 28 on the right side. Well, since it's not possible for 4 to equal negative 28, we say that this problem has no solution. Or we give the solution as the empty set, that 0 with the line through it. Now, if you want to experiment with this a little bit, you can try some different answers and see what happens. Putting 1 in for p, 9 plus 4 would give you 13. 2 minus 7 would be a negative 5 multiplied by 4, which is a negative 20. And when you add 1 to negative 20, you get negative 19. So sure enough, 1 didn't work. And going on trying that, you'd have to try every number that exists, which isn't really possible, but you never will find a number that will make this solution true because all of our p's canceled out on both sides. Let's look at an example that has all real numbers as its solution. So we start solving this the same way we've solved all of our other problems, using the distributive property to distribute that minus 2 onto the y. Remember, minus 2 times minus 8 is going to give us a positive 16. Then we're going to combine our like terms. 5y minus 2y is a 3y plus 16. We also have 3y plus 16 on the left. Subtracting 3 y's from each side so that all of our y terms will be on the same side has, once again, the y terms canceling out. And we're left with 16 equals 16, which it does in every case. So we say that this number, this solution set, is all real numbers. Or the shortcut way of writing that is that letter R with 2 lines in the front. So experiment with this a little bit. What happens if you put 1 in place of y? Well, 3 times 1 plus 16 is going to give us 19. And if we put 1 in place of y over here, (1 minus 8 is a negative 7 times a 2 is a negative, let's do that, the steps written out. 5 times 1 is going to be 5 minus 2 times negative 7. Well, a negative 2 times a negative 7 gives us a positive 14, which when added to 5 is 19. So not so unusual. We've been seeing that in our checks all along. But try the check again using a different number. Let's say negative 2 and see what happens. 3 times negative 2 plus 16 gives us a negative 6 plus 16, which is a positive 10. When we check that same answer on the right side, 5 times negative 2 minus 2 times negative 2 minus 8. Negative 2 minus minus 8 will give us a negative 10. When multiplied by negative 2, we get a positive 20. This 5 times negative 2 was also negative 10. And negative 10 plus 20 gives us a positive 10 on the right side as well. And that hasn't happened before. And if you check any other number, try putting in a 5 or a 7 or a decimal or a fraction, you're going to find that no matter what you put in for y, the answer always comes out the same on both sides. So that's why we say our solution for this problem is all real numbers.